Hi and welcome. My name is Sjoerd de Jong and welcome to this course on Material Essential Concepts. We're going to go through all of the essentials of working with textures and the material editor in the Unreal Engine. We will look at texture sizes and compression and how to import them. We will build our first material and talk through how to work with physical-based rendering within materials. And then once we have got that covered, we will dive deeper into the material editor itself by going through common expressions, material inputs, and other material properties such as the different shading modes and blend modes. We will go through all of these topics by building small but fun examples. For instance, a material for a curtain moving in the wind, or a rock material that blends in a grass texture at the top of a model it is applied to. Welcome. In this chapter of the Material Essential Concepts course, we're going to look at textures. What we would like to do is import a number of textures from a door into the Unreal Engine. And by doing so, we're going to have to take a look at texture sizes and requirements that come with it, common formats used, the actual process of importing textures, and a brief word about compression. Now, as part of the content that came with this chapter, you will have these 4 textures over here. And if we open them up in Photoshop or any other package of choice, we will get this. This is the diffuse texture. You can see _D from diffuse, _N from normal map, _M from metallic, and _R from roughness. Now, exactly what the metallic and the roughness map do, by the way, we'll cover that in a later chapter. Right now, the most important thing for us is how do we get these images into the Unreal Engine. And to do so, we need to make sure they have the right size. So in image size, you can see it's set to 2048. It has to be exactly this number or a similar one to it. These textures are already the right size, but if you look here back at my slides, it has to be one of these values for it to be correct. So 1, 2, 4, 8, 16, 32 and all the way up to 8192, power of 2 essentially, those are acceptable values. Combinations are fine too, so a texture could be 16 in width but 4096 pixels in height. That's fine too, but it has to be one of these numbers. If you would import something that's not one of these numbers, that's a different resolution, it will still import and it will still seemingly look okay, but those textures will not have MIP maps. Now, exactly what MIP maps are is kind of a deeper discussion and is a little bit too much for an introductory course, but essentially a MIP map is a smaller version of the same texture. So the engine will generate different resolution versions of each texture it imports, so that in the distance, rather than displaying the full resolution image, it can display the lower resolution texture or image. And by doing so, it will save memory, it will make it easier to stream in textures as well, and it will visually smoothen out the image a little bit. So long discussion what MIP maps are, exactly how they work and exactly when you need them. So essentially it goes like this. If you're uncertain whether or not you need MIP maps, you probably need them. 95% of the content needs MIP maps. Therefore, if uncertain, always stick to one of these numbers and you'll be fine. You can't go wrong then. So the next section would be about format of the textures. You can see the textures you had with this chapter are TGA files. If you do save as, you can see they're Targa, TGA. And I'm going to switch back to the editor, and you don't have to copy me here, I'm going to do this very fast, but I simply want to have the list here of formats supported by the engine. It's a little bit big, let me rescale this for a second. You can see in the import dialog of Unreal, you can see all the formats that it accepts. And you can see an entire section here on texture. So these are all the texture 2D formats except. I think there's a couple more, some left and right in the rest of the list, but these are the most important ones. And out of this list, we mostly care about PSD, the Photoshop files themselves, or again TGA. PSD is used commonly because it's simply very handy. Because while working in Photoshop, you don't have to resave your image in a different format. You can simply import your working file PSD and it'll simply work. But TGA is also commonly accepted. TGA is essentially uncompressed, but with support for alpha channels, which makes it the preferred choice. Bitmap, for example, doesn't really have the same level of support, even though it's also uncompressed. JPEG and the others are not advised because they have compression in them. So PSD or TGA. And by the way, it doesn't matter really which format you pick. Once imported into the engine, it is going to be compressing it. And that's what we're going to talk about later on in one of the next few sections. But the compression will cause all of these to become the same format internally within the engine. So whether you've imported a 1 GB large PSD file or say a 1 MB large JPEG, internally it becomes the same type of file with the same file size and the same style of compression. Either way, PSD or TGA. Now, in terms of importing these, there's 3 different ways of doing it, and it's all the same. So in the content browser here at the bottom, in the folder where you would like to import the textures, and I'm currently in, if you don't have this list of folders by the way on the left, it's this button over here that shows you the folders. And I'm currently located in Fundamentals, Materials, Essential Concepts, and then Start Assets. And in Start Assets, I'm going to right click in the empty space here on the right, and I'm going to do Import To. I will navigate to where we have the textures saved. In my case, that's over here. And you simply select them there and press open. Now, I'm not going to do that because I'd like to show you the second way of working. So I'm going to cancel that and press the button import here. And that does the exact same thing. So I'm going to cancel that again as well. And the third way of working would be to simply use Windows Explorer, select the textures in there and simply drag them to the content browser. And if you wait a couple of seconds, that will also import your textures. So there you are, you have your textures ready to go. You can immediately save them if you'd like. You can right click them and do save. And you can see that removes a little asterisk symbol on the bottom left. That means they have now been saved. Now, as mentioned, textures are compressed. By default, they compress the moment you import the textures, and they will compress to DXCC or BC. Now, these terms and these names are a little bit important because that allows you to identify if they're actually compressed or not and how they're compressed. You can see on the textures that we've just imported, if you were to double click one of them, let's take the diffuse one, then you will get this window that pops up with the texture in here and some additional detail on exactly what it is. Now, there's all kinds of settings here you can work with and modify. Most of the time you will not need to touch almost any of these, so there's not too much important information to mention here for an introductory course. The one thing I simply want to mention is the compression settings. You can see here, if you click there, these are all the different types of compressions you can pick. By default, it will take default, which means it gets DXT or BC compression. That's the default compression format. If it's a normal map, it would automatically set it to normal map. So you can in fact see if we open up the normal map we imported, it's set to normal map. That's it. So it never uses any of the other ones by default. And in fact, 95% of the time you don't want to touch these two. Simply leave them be at these two and that's it. There are times, however, especially if you're working on content that's not meant for games, if you non-game usage of the Unreal Engine, you might want to turn this off, and in that case you might want to experiment with some of the other settings available here. You can see here in the top right it says format DXT1. So it's now compressed to the DXTC format type 1, because they have different types within the format. That means it's compressed. You can see if I were to set this to, for example, a grayscale, it obviously becomes grayscale here, but the format also changes to BAG8R8AA. That means it's uncompressed. So if you see this like kind of long format over here, it's uncompressed. And you can simply experiment a little, see what happens. Again, float RGBA is also uncompressed, and so on. You can also, by the way, see the resource size, and it also gives you a good idea whether it's compressed or not. This is now currently 43,000 kilobytes, and if you go back to default, it's only 2,700 kilobytes, so it makes a pretty big difference. But again, to wrap this up, most of the time you don't want to touch this, just leave it be, but be aware of the fact that textures are getting compressed and slightly modified the moment you import them, and sometimes maybe you would like to turn it off for a particular texture where it's noticeable or desirable to have the absolute highest quality. Great, so we've just gone through the process of importing the textures for a door, and by doing so we've taken a look at texture sizes and how they should most preferably be power of 2. Texture formats, it's preferred to use TGA or PSD. The process of importing importing textures, which you can do in 3 different ways, but it all results in the same result, and the fact that textures are compressed the moment you import them. Welcome. Material Essential Concepts is the course we're currently in, and in this chapter we're going to take a look at how we can create our very first material, which means we have to go through a basic material editor user interface overview, and then we're going to create the actual material itself. Let's switch to the editor. So I'm in the level called Essential Concepts _start. This is a basic area we're going to be working in, and we're interested in the first little thingy over here in the beginning called your first material, and this is the model of the door that we would like to have the material made for. Now, if you followed the previous chapter, you will have the textures imported over here in Start Assets or wherever else you put them. If you did not follow it, you can still follow along, because in Essential Concepts /Finished Assets, we find the same 4 textures as well. I mean, slightly bigger for you. The same 4 textures over here. So those are the ones we're going to use. Now, somewhere in here, and by the way, if you don't see the folder list on the left, it's this button over here, shows you the folder list in the content browser. Now, somewhere in here, I'm going to do this in Start Assets. I'm going to create a new material by right-clicking in empty space. So somewhere in the empty space, right-click, New Material. Now that needs a name. The standard naming convention we have usually comes down to M from material _, and then the name of what it is. So do example door material or a similar name. And then we can open up the material and we get this. This is the material editor. Now it has a lot of functionality. It's actually a very powerful tool in the Unreal Engine. I'm going to briefly step through the interface. In the middle, which is the absolute most important part of it, this is the space where you're working. This is the space where you will be connecting different nodes together in a style of visual scripting. And you can experiment a little bit with this right away, because on the right side you can see this long list of things. It's a very long list. Just take any random one of them. It doesn't really matter which one you pick. Just take something and drag it into the view in the middle. See, I'm just taking random things I find here, drag them in, and you can see we get these nodes in the workspace. That's how we're going to be working. We're going to create these nodes, and then we're going to connect those nodes together one by one. You can simply click and drag one of the connectors to somewhere else and you create a line. If you click and drag on the actual node itself, and these are often called expressions, so node is an expression, then you can move them around. Now we're going to come back to this later on. I don't need these right now, so I'm going to simply delete all of it, and we're back to where we are. This big block that you already have there, that is the input of the material itself. This is what will be displayed. So these are the inputs that need to be filled with something. Not all of them have to necessarily be filled, but something has to connect to some of these in order to show up over here on the left side, because this is the preview of the material that we're creating. In the bottom right, you can set this to different models. You can set it to a cylinder, sphere, plane, cube, and the last one is special. If I click that, I'll get a warning. The last one takes the currently selected model in the content browser and uses that in the material editor instead. So you can use it to preview a different kind of model than these primitives. Now I don't have anything selected, so it gives me a warning, and I don't need that right now either. I'll leave it be to box. Beneath that, you can see the detail panel. These are the properties of whatever you have selected right now. I have nothing selected right now, so it simply shows me the properties of the material as a whole. So these are the properties of the actual material itself. There's nothing we need to do there right now, just pointing that out. And then in the very bottom, in the center, we have the statistics panel. It might be that you don't have this visible in your view. In that case, it would have been, you can enable it here in the window. But it's not very important at all right now, so we can just leave it be. It shows you a little bit of statistics of essentially how expensive the material is, but that's not information we need right now. I'm going to turn this window back into windowed mode so I can have it open alongside seeing the content browser, and then we're going to simply drag the textures from the content browser. So I'm going to take all 4 textures from the content browser into the central space in Material Editor, and we get the textures in the Material Editor. You You see they're called texture sample, so that's the expression type. And we can line them up in this order. That's the order we're going to need them in. And we'll move them a little bit closer to the node at the end. So diffuse first, then the metallic map, then roughness, and then the normal. You can also see if you click one of these, you can see the properties here in the bottom left change, and you can see this is the texture assigned to this texture sampler expression. Now the diffuse is going to connect to base color. So I'm going to take the top right color output on the right side. This outputs all the colors together, red, green and blue and alpha. Actually red, green and blue without alpha, sorry. But it takes all of them together and connects to base color. Then this one connects to metallic. This connects to roughness. And normal is connected to the normal map at the bottom, and we end up with this. And you can see already here that the material shows up. It's nice and shiny around the hinge parts and the doorknob part, whereas the rest is a little bit less shiny. The wood is less shiny than the metallic parts, so that's nice. And we have a very first basic material. If ever you would like to disconnect things, by the way, you can right click one of the connections and it says break links. But since that's a little bit annoying to do, I think personally I usually alt click. So if you alt click a connection, you also disconnect it. Now we have to, in order to apply this to the model, we have to make sure it's compiled. Materials have to compile to a shader. This happens in the background, but you simply have to tell it to actually start the compile. So if you press apply, it will do this. In fact, if you press save, it will also apply and save at the same time. So usually when I'm working, I simply press save because it does both at the same time. You can see it's now going to gray out apply once it's done because it has compiled. Once we're done here, we can close the material editor. We have our material over here and you can apply that to the door. And you can see the material showing up. It might take a few seconds before you see the material showing up on the model. This is normal. It is due to some additional compiling steps it does in the background the moment you apply it to a model. So the first time you use it, it might take a few seconds before you see it appear. That is perfectly normal. And as you can see, the door shows up nicely, material on the door. And we've made our very first material. So we've taken an overview of the material editor and its user interface, and we've created our very first material by making a simple door material that we've applied to the door in the level. As part of the Materials Essential Concepts course, in this chapter we're going to take a look at PBR material, and we're going to take a look at what PBR is and how it works, PBR material values, so how it is actually used within the material editor, and after we've learned about those things, we're going to take another look at the door example from the previous chapter. So PBR stands for physical base rendering, and it's an approximation of what light actually does as opposed to what we think it should do. PBR-based materials will work equally well in all lighting environments, and material values can be less interdependent and more locked down, resulting in increased efficiency and ease of use. So lots of fancy words. It essentially means PBR will make it easier for you to create content, and that content will work consistently well in all kinds of different usage scenarios. PBR essentially means that you approximate the shading of the materials and the interaction it has with lighting through the altering of the metallic, specular and roughness properties. So there are three properties in the material that control the PBR shading. This is used for almost everything we do in Unreal with materials. Almost all materials are PBR based. There's a few exceptions, but they're not so important right now to talk about that. And because of that, because it's used for everything, it's what we call unified shading. Now in the editor, I'm going to create a brand new material somewhere. In my case, I'm going to do this in Essential Concepts Start Assets. And again, if you don't see the folder panel on the left, it's this button in the content browser that shows you the folders. Start assets, and I'm going to create a new material. I'm going to call it M from material again, underscore PBR example. I'm going to open it up. And here we have the material editor. Now, what we've done with the door in the previous chapter is we've connected it to base color, metallic, roughness, and normal. Those were the ones we've used. There's also specular. So metallic, specular and roughness, these are the three controlling the PBR values. So we're going to have to work with those three. Now for base color, in order to have something that we can work with for now, I'm going to simply connect a color. If you right click, you get a list of all the things you can add. In fact, this list is equal to the list we have on the right. So you could technically also be searching over there. I right click, and in this list I look for a constant tree vector. And then right away I'm going to do this again. I'm going to look for a constant. And in fact there is a shortcut to get a constant or a constant tree vector. If you simply hold the number 1 on the keyboard, and while pressing down 1, you click somewhere, you get a constant as well. If you press and hold number 3 and you click somewhere, you get a constant tree vector. And likewise 2 and 4 would give you a constant 2 or a constant 4, but we don't require those right now. The one with 3 zeros, that's the constant tree vector, is base color, and then the other 3 zeros are 1 by 1 metallic, specular, and roughness. The base color, we're going to set it to a certain color. Anything goes, but preferably pick something like gray or a pretty neutral color to make it easier to work with. Maybe slightly greenish or so. Just don't go too extreme color wise, and we'll OK that. So now we have a very basic material that essentially simply has a flat color assigned to it. And then we can take a look at metallic. So metallic, and all 3 of them, by the way, they operate between 0 and 1, so they have a maximum value of 1. They're currently all set to 0. The default value for specular is actually 0.5, so I'm going to put the specular one back at 0.5 for a second. And I believe the default value for roughness is 0.5 as well, if I can remember correctly. So this is the material if you wouldn't have anything connected. In fact, you can see this. If I disconnect these 3 for a second, this looks exactly the same. These are the default values if you connect nothing. The roughness value is the most important one, I would say, and the one that's most commonly used. If you set roughness to 0, it becomes fully reflective. Essentially it becomes not rough, it becomes smooth, and if it's smooth, it's reflective. PBR works on the assumption that almost everything in the world is at least slightly reflective. So every material is actually slightly reflecting the environment. It might not be obvious, but almost everything is. So roughness 0 gives you the reflection of the world in the material. Roughness 1 completely removes that reflection. Roughness 0.2, for example, gives you some form of reflection, but it's rather vague and it's also rather blurry. So you can experiment a little bit with the numbers and see what happens if you change the numbers and what you're getting. It can help, by the way, to put the color or base color to a little bit darker color. It might make it easy to see what happens reflection wise. Now specular is often not used. So in a lot of materials we actually don't even touch specular, we leave it disconnected. Technically, if you would set specular to 0, you would remove all reflection of light, which includes the reflection. So both the specular highlight of where light might be hitting the surface and reflecting away from it, and the actual reflection itself, they will be removed with specular 0. But again, if you're new to this, just leave specular at 0.5. And then there is metallic. Metallic is 0 by default. If you set it to metallic 1, essentially it becomes a metallic surface. So metallic 0 means not metallic, metallic 1 means yes, it's metallic. That's essentially it. And when it's metallic 1, in simple terms, it kind of becomes darker, the surface, and it becomes much more reflective. So again, if you're new to PBR and how this works, try to play around a little bit with these 3 numbers, in particular metallic and roughness, which are the most important ones. Specular you can ignore for now. Play around with these 2 numbers and see how it changes the look of the material. You can, by the way, assign it to the sphere in the level here as well if you'd like to see the material applied in the level itself. Now take another look at the door that we just made in the previous chapter. If you went through the previous chapter, you will have your example door material over here in Start Assets. If you did not follow the previous step, you can also find the same material in Finished Assets. And here we also find your first material underscore M underscore door underscore simple, which is the same setup. If you take a look at that, we can see we use metallic. We don't use specular because, again, usually there's no point changing that. We only use metallic and we only use roughness. In metallic, you can see this is the texture that we're using. I'm going to double click it here in the texture property here, and it opens up the texture by itself. And what we did is we said that all the parts that are hinges or part of the doorknob, that is metallic. So we colored that white. We colored it by color 1. It's white. It's 100% white. And everything else is black. So that is how this texture was made. Everything that's metallic was simply colored white. Everything else was simply colored black. If you're new to PBR, it usually works well to use the metallic property on a Boolean basis. So simply treat it as no metallic is black. Everything that's metallic is 1. Don't try to use in-between values. For roughness, it's very similar. Texture looks like this. What I did here is I took the diffuse texture and I inverted it to make sure that the darker parts of diffuse actually become white in the roughness map, because white means less reflection. So I can get the darker parts of the diffuse image to reflect less, which means the lines in between the wood and damage done to the wood is reflecting less. And everything again that's metallic, that is going to reflect a lot of light, so we need that close to 0. So this is about 0.1, I think, or in other words 10% white, 10 to 20% white, I think, the parts that make up the locks and the hinges. And then that becomes a roughness map, which in turn results in this. You can see it's shiny around the knob and the hinges, but the wood itself is only slightly reflective. And that is PBR in a nutshell. So we've taken a look at what PBR is and how it works, how you use it within the material editor with metallic, specular and roughness. And with that information we took another look at the door example and how we've used PBR within the door that we've made in the previous chapter. Welcome again. We're moving forward in this course on material essential concepts, and in this chapter we're going to take a look at material expressions. So we're going to take a look at what an expression is, the most common ones, how to combine them, how to search them, and how to work with larger networks. Material expressions are essentially the nodes in the material editor, so the nodes that make up the graphical network where you do most of your work in the material editor. Now if you open up the material we're going to use for this, and we're by the way still in the level called essential concepts _start, same level that we built the door and the PBR material that's applied to the sphere here in previous chapters. And now we're going to work in material expressions, which is this big flat surface in the middle here. And we're going to create a very simple yet very cool natural surface for this. So we're going to create a small surface where we blend rock and grass together, and there's a pool of water in the middle. There's a material in materials / essential concepts / start assets, and the material is called material expressions _m _ groundwater. So this material is the one we're going to use. And if you open that up, you will get the material as it is, as you can see it here. And you can see we have a whole number of textures in here. So this is what we're going to be using. But before we go there, let's first focus on the most common expressions. Because as shown a few chapters back, this is a very long list of things you could possibly add to the workspace in the middle here. It's a very, very long list. And it's rather intimidating, I'm sure. But the thing is that 90% of the time, you will only use about 10% of this list at most. So most of the things you see here are extremely specific. The great majority of work that you will be doing will be done with a very small selection of expressions. So we're going to take a look at the absolute most common expressions in this chapter, and what we can do with a very small number of expressions already. The absolute most important expression is the texture sample itself, because that holds the texture that you're using in the material. So these are all texture samples. The next one that is rather important, I would say, is the constants. So that's what we did in the PBR chapter as well. If you right click and in the right click menu, you look for constant 1 essentially, constant 2, 3 or 4. You can also use the shortcuts on the keyboard. So 1, 2, 3, 4. If you press 1 and hold 1, and while holding 1 you click somewhere, you get a constant 1, 2, 3, 4 for numbers 2, 3, 4. Now the constant 4 and the constant 2, these two, they're a little bit more specific in use, and we don't need them that often, so I'm gonna delete these again and simply focus on the constant and the constant 3 vector. A constant is a single value. You can see here is the value. Therefore, it represents a grayscale color. You can see the color if you press the little triangle that points down. You can see it's currently black because the value is set to 0. If I set the value to 1, it will be white. If you set it to 0.5, it will be gray. This one, the constant 3 vector, is an actual color. So it has 3 values in there, red, green and blue, and therefore you can pick a color. I'm going to pick a slightly bluish color here that we're going to use later on for the water. And we have the color. The next one that is very common is a texture coordinate. So you can look up texture coordinate. You can also look it up in the list on the right, by the way. You can see it's the exact same list. And if you use the list on the right, you also see the shortcut for it. It's a little bit on the very edge of the screen here, but you can see the letter U. The shortcut for texture coordinate is U on the keyboard. Now, a texture coordinate has to be connected to the UV's input of a texture sample, like so. If you then were to preview this texture or this texture sample, so I'm going to right click it and I'm going to do start previewing node. So it shows only this expression, this node. And I'm going to set the preview to a box because it's easier to see. You can see this is the texture assigned to the box. I'm going to set texture coordinate. If we click it, we can set the texture, the coordinate index, but that's too advanced right now, so I'll leave that be. But U-tiling and V-tiling is essentially the scale of the texture. If I enter 2 there, the texture is twice as small. You can also add a panner or P on the keyboard if you want a shortcut. And if you add it in between the texture coordinate and the texture sample, and then in the panner say speed is say 0.1, it's moving. I'm going to move this up here. Another one is multiply. So if you add multiply, you can multiply 2 things together. So let's say we multiply the blue color with the texture. If I then right click multiply, I can start previewing that one. And you can see now it's blue. So we've colored the texture blue by multiplying it together with this value. If you multiply it together with the constant, it essentially becomes control over the brightness. You can see if you set the constant to 0.1, it becomes darker. If you set it to a very high value, say 5 or 10, it becomes brighter. And then lastly, you also have lerp. So look for linear interpolate, or abbreviated it is lerp. Linear interpolate, or commonly referred to as lerp. Lerp will blend A and B together based on C, based on the alpha. And we'll demonstrate this in a second when we start building the material. But for now, quick recap. If you're new to the material editor, do not get overwhelmed by the very long list of options you have, different expressions you can pick from. The only thing that is important for you right now is constant 3 vector, texture sample, texture coordinate, a panner, multiply, and lerp. If you start off by learning these 7 of them, you'll be a long way already. Next part, I'm going to demonstrate just how powerful these 7 are and how far you can go with just these 7. So continuing from the previous section, we're going to build the actual ground material itself using these 7 very common expressions. I'm going to delete these that I just added, and in fact I'm going to delete the multiply, I'm going to delete the lerp, I'm going to delete essentially most of it. Actually, let's just delete all of it and go back to the material, and the material is material expressions _m _groundwater that you will have found within the materials essential concepts start assets folder. And now we're back to the material as it was when we opened it up for the very first time. The first thing we're going to do is we would like to blend grass and rock together. So these two, and in fact this one and this one as well. because this is the corresponding normal map for that rock texture and the corresponding normal map for the grass. We're going to blend these two together based on this. This is the alpha. So essentially we layer it together. So we use a lerp. And you can see we're going to use the rock as A and the grass as B, and the alpha is this texture over here. We're going to do the exact same thing for the normal map. So that's A, that's B, the alpha is this one over there. So what we have now is this. Then we're going to connect the normals to the normal input at the end here, and base color is the other arm over there. We have is now this. You can see already in the preview that you have a blend between some grass and some rock. But that's very nice, but let's say we'd like to have a pool of water in the middle. In fact, the texture we have over here, where it's black, it should become water. So let's start off by modifying the base color itself. Let's make it a little bit bluish, where this is black. So we're going to add another lerp. And that lerp is going to use the alpha, as alpha is going to use this texture over there. So it's connected. You can see this is black. Black means A will be used where this is black. A will therefore be water. So I'm not going to connect A to anything yet, but B will be as it was. So B is going to be connected to what I already had. In a way, this is similar to layers in Photoshop. You're essentially just layering the different effects on top of each other. And this will then go to base color. You can see this made the middle black, because there is nothing assigned to A. But if I were to assign a constant tree vector to A, and I colored that one a little bit bluish, then we have a blue spot in the middle. In fact, let's go for a little bit darker blue slightly. You can, however, still see the normal map from the rock coming through, and in fact the grass as well, because the normal map hasn't been modified yet. So let's do this again over here as well, and let's have another lerp. B is as it was, alpha is this texture over there, and this then connects to normal. So exact same setup again, but replicated for normals as well. Now this looks rather weird because we've inputted a black input into normal as part of A here. So let's say we're going to take this other texture here, the water texture, and we're going to input that as A instead. Then we get this. You can see it's starting to look somewhat waterish. Still rather strange. It's not animated for one, and you expect water to move. So let's fix that. Let's take this texture over here, which is now essentially the water surface itself, and let's add a panner next to it. And connect that to UVs, and then in the panner we're going to give it a certain speed. Now this is going to be very small speeds. It doesn't matter if you pick speed X or Y, just the direction, but the value should be 0.01, so very small value. And now we have a panning layer of water in the middle of the surface. It's still not entirely realistic, however, so let's see if we can take this another step further. In fact, it would be more realistic if it's not just a texture scrolling across the surface, but if it's two layers. So if it's two layers of water interacting with each other. So let's take these two and let's copy paste it. So simply Ctrl+C, Ctrl+V, or if you wish Ctrl+W, which does the same thing. So now we have the same again. Then multiply both of them together. So I'm going to add a multiply here, and I'm going to multiply the first one with the second one, and then that's going to replace the original input we had on the lerp A. Just drag it there, it will automatically disconnect to Alt9, as you can see. And then we're going to set the panner of one of the two, it doesn't matter which one again, one of the two has a slightly different speed or direction. So I'm going to say speed X is 0.01 as well, so now both speed X and Y are 0.01, but only on one of the two. The other one is still set to 0 on speed X. If you start looking closely, it starts looking a little bit more interesting here. Still don't think it's good enough, so what I'm going to do is I'm going to scale this one, the second arm, I'm going to scale that one a little bit smaller. I'm going to add a texture coordinate left of it, connect it to coordinate, And we're going to say actually the second layer of water should be a little bit smaller in scale. So I'm going to say 1.25 on U tiling and V tiling. It will give you a little bit more extra variation, which I think is quite nice. And now we have this. Now that is still not very realistic. And by the way, it should be mentioned also that the act of multiplying two normal maps together is not 100% correct. The more correct way of working would be to use blend angle corrected normals, which is a special, it's not even actually an expression, it's a function. But this goes too far and is too advanced. So to keep it simple, I'm simply multiplying it. But just for perspective, this would have been more correct. Either way, it's still not very realistic, right? So the shading is actually incorrect. It's very strange. It doesn't really look like water. Water is more contrasted, water is more reflective, and so on. Which means that we're going to have to work with the PBR materials here, values, to get it to look more like water. Now it's going to have to blend between everything that's not water and everything that is water. Which means I'm going to add another linear interpolate here and then another one underneath. This will be the linear interpolate used by metallic. This will be the second one will be the linear interpolate used by roughness. So both metallic and roughness are changing values based on this alpha. And that alpha is going to be this, because this identifies what is water and what is not water. So you simply connect this to both of them. There we are. Now you get an error. And this shows you what happens when you get errors as well. So this is an interesting one. And you can see here that if you hover over it, it says it failed because float 3 went through float 1. Errors like those, if you get them, it means that some information was inputted that wasn't expected. This expects a float 1 input, and it's a little bit hard to know exactly what it expects, by the way, if you're new to it. So often you simply try it, and if you get an error, you know it was the wrong type. This expects a float 1, it expects one value of information, but you've inputted RGB, 3 values of information. So the solution here is to simply take red, green or blue, or here, doesn't matter, and then connect that to alpha instead. And it removes the error. And we're almost there now. The reason, by the way, why the alpha here did survive being connected to RGB, because the white one stands for RGB, is because base color and normal is less sensitive. Metallic and roughness a little bit more sensitive, so the error popped up. Technically, this is not entirely correct as well. You could have technically done this too, and it would have looked the same. Either way, we're almost there now. The only thing we have to do is change the values of both of these lerps. So in the first one, we're going to say A is 1, B is 0. So essentially, water is metallic 1, ground is metallic 0. And in the second one, we're going to say A is indeed 0, because the water is 100% not rough, it's 100% smooth and reflective. And B is, let's say, 0.8. That's essentially how rough the ground is, the grass and the rocks. And the end result is this. Here's the entire setup, if you'd like to compare with what you have. I'm going to save that. And we're going to apply that to the surface in the level, just drag it on top. Again, it might take a few seconds before it appears due to compiles and internal compiles, but eventually we'll get this. It's very simple, it's very basic, it's not the prettiest water ever, but it shows you how quick and how easy it is to get nice little effects going on, and how you can blend different layers and different textures together using just 7 different expressions. And with those 7 different expressions, you've made a relatively large network of large graph in the material editor. So in these 2 sections, part of this chapter on material expressions, we've gone through what an expression is, the most common ones, so those 7 you've seen, how to combine them, how to search them, and in general how to work with larger networks, because we've built this rock, water, grass material as an example. Welcome back. As part of this Material Essential Concepts class, we're going to take a look at material inputs. We're going to take a look at what they are, and the default available inputs, which means base color, the physical base rendering ones, normal maps, emissive and world position offset. Now, because in previous chapters we've already covered base color and the PBR ones as well as the normal map inputs, we're primarily going to cover emissive and world position offset in this chapter. Switching back to the editor, I'm still in the level essential concepts _ start, and we're at the section here that's called materials input, which has a curtain and a spotlight. We're going to make sure that the spotlight appears to emit light, and we'd like the curtain to be moving in the wind. In the folder materials essential concepts start assets, we got two materials that are used by these two models. The curtain one there called m_curtain and m_round ceiling light. Let's start off with the light because it's the easier one to start with. So we're going to open up that material. And then in the material editor you can look at the material already made here. You can ignore everything that's already here except this texture, because this is the texture we're going to be using for emissive. But before we do that, let's take a look at the material inputs themselves and what they are. These are the material inputs. So the inputs you have available on that large node at the very end of the material that everything connects to. Those are the material inputs. And as you can see, a number of those are enabled, about half of them, and about half of them are disabled. Opacity, for example, opacity mask, and so on and so on. Those are all grayed out. The ones that are enabled or disabled depends on the settings over here in the bottom left. It says material domain, blend mode, and shading model. The combination of these three settings determines which inputs are enabled or disabled. So for now we're going to leave this be. In the next chapter we're actually going to take a look at what happens if you change these three properties, but for now we'll leave it be and focus on the default enabled ones. Now, as mentioned, base color, metallic, specular, roughness, and normal we've covered in previous chapters. That leaves us with its emissive, world position offset, ambient occlusion, and pixel depth offset. Now, pixel depth offset is very specific and is a little bit advanced, so you definitely don't need this for day-to-day usage. Ambient occlusion does, as the name implies, it allows you to have ambient occlusion applied to the material, but it actually doesn't work in every scenario. There's a couple of very specific bits and pieces about that. And because of that reason, it's not actually that commonly used either, plus it's pretty self-explanatory, so I'll leave that be. So that leaves us with emissive and world position offset. We're starting with emissive for this light. Emissive means that the material is unaffected by lighting, whatever is dependent on what's inputted in emissive color. So if you were to input a simple constant tree vector, just right click, type constant tree vector, or the number 3 on the keyboard as explained in previous chapters, and you input that to emissive color. Now it's black, so nothing happens. But if you make this not black, say 1 on red, the whole thing becomes red. Even down here where there should have been shadow, it is still red. In fact, if you were to apply this or save it, and then move the window out of the way for a second, and then look at the lamp in the level, you can see it's really glowing. In fact, you can get it to glow even more if you were to change this number to something that goes over the value of 1. And it should be noted that this is harder to do if you use a color picker. If you use a color picker, the values will clamp to 1. So I'm not going to use a color picker. Instead, I'm going to actually type the value underneath. Make this a little bit bigger. You can see if you expand it, you can actually type the color in numbers. If you type, for example, red 50, and then apply that, let's look in the level as well, you can see it starts to glow. So in essence, this controls the blooming as well. Now, this is not a very realistic spotlight, I'd say, so let's make this a little bit better. We're going to use a texture, in particular this texture you already have here, and this texture is going to identify what's not giving light, what's not emissive, and what is emissive. So black is not emissive, the whiter parts are emissive. If I were to connect this to emissive directly, then this part would be unaffected by light. So that's already pretty okay, but we'd like to control the color as well. So what we will do is we will multiply the texture with a color. Let's just take the color we made earlier and then connect that over there. And what we have now, if you put it to a box, you can very clearly see at the bottom, for example, The surface itself is black because there's no light, but this is emitting light. And that's emissive. It's useful for anything to do with lamps, fires, anything that naturally gives off light, TVs, anything like that. So I'm going to close this. We're done with the lamp, and then we can move on to world position offset and the curtain. We're interested in world position offset. Now, world position offset is an interesting one. It essentially uses the vertex shaders underneath the hood, and it uses the vertex shader to offset the model. So this actually offsets the model that the material is applied to. I can demonstrate it very easily if you add a constant tree vector to this one as well. Constant tree vector directly inputted into world position offset. These values are no longer representing a color now, but it's now representing a position in the world. So RGB is no longer RGB, but actually XYZ. So therefore, if I were to enter, say, 50, it means move 50 units on x-axis positive. See, the sphere moved to side. In fact, let's take a bit of a bigger number so it's more obvious. Let's type 500. You can see the sphere is now there. It actually offsets the model itself that it's applied to. And there is in height 2. Experiment a little bit with the numbers. It moves it. That's very fun, but it doesn't really help our curtains. So what we'd like to do is we'd like to simulate wind. We're going to simulate wind by taking the texture we have over here, which is a simple noise texture. I'm going to take that noise texture and we're going to be moving it. So we're going to add a panner that was discussed a few chapters back. So panner. It's the P on the keyboard. Letter P on the keyboard is a shortcut. You can also just right click and search for it. And then we'd like to change the scale as well. So I'm going to add a texture coordinate. Texture coordinate is the full name because the node abbreviates it. To the left of it and connect that to coordinate. Now, texture coordinate scales it, and we need to have it a bit bigger scale. So we're going to bring the number down to 0.15. So 0.15 for both U and V. And in the panner, we're going to say X speed is 0.05, Y speed is 0.1. Now, if you right click the cloud texture sample and you take start previewing node, in fact, I usually set it to a box. I think it's easier to see, so I'll put it to a box here. This is pretty hard to see, but the texture is scrolling by. It's simply so big that you don't really notice it, but you can see it got a little bit darker there on the edge, and now the darkness moved away again. That subtle difference is going to be enough to be used for the position of the curtain. So we'll add a lerp here, and I will use the cloud texture here as the alpha for the lerp. Now, as shown in the previous chapter, if you would do this, it might not work. It's more correct to use red, green, or blue. So for the same reason here, I'm going to do that again. And then we're going to input two different constant tree vectors for A and B. So I'll take this one here as the first one. I duplicate it, Ctrl C, Ctrl V. And that's the second one. And let's input that to world position offset. So now we have that. I'm going to stop the preview here. And then I'm going to set this to two different values. So let's say this seems to work well. Values that I've been using -2 on the first constant tree vector, red -2, green 10, blue 0. On the second one, I went for red 40 and green 110. The values don't really matter that much. You're very free to experiment with this. This is essentially just how much the curtain is moving because of it. And you can already see the box starting to shift here and move aside. In fact, if you look at the level, you apply it, and then let's take a look at the level. We are now having this. So the curtain is moving, but it's not moving as a whole. It's moving section by section. It's actually applying different motion to different vertices the model is made up of. Now, as final added bonus, one thing that I did in the finished asset, you can find in the finished asset directory, is at the top of the curtain is moving as well, which is a little bit strange because the top would be attached to some type of rigid object. So in order to make sure that the top doesn't move, what I did is in the curtain itself, you don't have to do what I'm going to do, I'm just going to quickly show you what I did. In the model of the curtain itself, there are vertex colors applied, and there is a black vertex color applied to the top, white vertex colors at the bottom. I will then let the material use these vertex colors to cancel out the movement wherever the vertex color is black. And if you'd like to do that, all you need to do is simply add another multiply behind the lerp. The line is routed through. And then add something called vertex color. So read the vertex color from directly within the material. Like so. And then again, to be correct, don't take RGB. In this case, it's better to take red, green, or blue. It doesn't matter because it's black and white anyway. For the same reason we did that there. So just take red, connect it to multiply, apply again, and we'll take a look at the level and we'll have it wrapped up. You can see the top is no longer moving, but the bottom is. World position offset is primarily used for some kind of visual animations and offsets. So vegetation is the most common usage of that. All the grass and trees and such you see in games and real-time rendered applications are very likely done with world position offset. Curtains would work well with that too. Water surfaces would work well with world position offset, but you wouldn't use world position offset for anything that requires collision. That's the thing. This does not support collision. So you only use it for visual minor animation work. But for that it works very well. So we've gone through what material inputs are, and we've gone through some of the default available inputs. Base color, the PBR ones, normal map, emissive, and world position offset. Welcome. In this chapter on material properties, we're going to take a look at some of the most common material properties we have available in the material editor, which means the shading modes, the blend modes, and two more important sections, one on two-sided and some translucency settings. Let's switch to the level. We are still in the level essential concepts _start. At the very end, we can see this little section on material properties where we have grass, at least the model of grass, a little statue, and a TV. We're going to create three different materials using the different properties I just touched on. There's no materials for this yet, so we're going to create brand new materials for each of these three objects. And let's start out with talking about the TV. Let's right click, new material, m_TV. You can do this in a directory of choice, by the way, but I'm in material/content/essential concepts/start assets. I'm going to open up the material we just made. Drag it over in the view somewhere here, and while the window is open, I'm going to go in the content browser to materials, content, textures, and we'll find our TV test screen. There's a T_test screen. Drag it into the material and we'll maximize the material. Now if you click an empty space, just click somewhere, you get the main properties of the material itself, and you can see it's quite a long list of different properties. Most of this you rarely touch and you rarely use. A lot of it is very specific for certain, for a very particular purpose, or it's advanced settings and so on. So we're only going to care about a few of these. We're going to care about blend mode and shading model to begin with, and in particular right now we're going to start with shading model. It's set to default lit, but we can also set it to unlit. This changes the way the light interacts with the material. So if you set it to unlit, you can see it grays out everything here except pixel depth offset, world position offset, and emissive color. And if you then connect the test screen to emissive color, you get this. You can see it's entirely unaffected by lighting. It's very similar to what we did in the previous chapter where we made the spotlight, but now the entire material is only using emissive. When we did the spotlight, we couldn't do this because the spotlight was partially emissive, partially non-emissive. The metal parts around the spotlight itself, those parts shouldn't be emitting light. They should be receiving light. So that's the case where you want to have it set to default lit but simply using emissive color. But this one, where it's the screen of a TV, the entire screen of the TV is emissive. It emits lighting, it doesn't really receive lighting. So here it's more optimized and cleaner to set shading model to unlit. And this is this added bonus. You can always add a multiply in between with a constant so you can control the intensity a little bit, and let's make it a little bit stronger, set it to 3. Also, if you were to look at the example I built myself in Essential Concepts / Finished Assets, the TV screen here, you would see it has a little bit of flickering animation, so that's an added bonus you could add to it, and feel free to check out what I've done there. But essentially this is it. Connect to emissive color, set shading model to inlet, we apply that, and let's assign that to the model in the level. And we've got this. It's very useful for any type of lamps, magical effects, fires, anything that only emits lighting and nothing else. That should all be set to unlit. Next up, let's do the grass. So I'm going to close the TV material I still have open, and let's create a new material for grass, m_grass. Same thing there. Let's open it up, let's drag it into the view, and let's find a texture for it. It's in the same place, material / content / textures. It's called t_fieldgrass_01_d. Drag that into the material here, and we're going to be using opacity mask. Opacity mask will become available if we set not shading model, but in this case blend mode, from opaque to masked. See, now we have opacity mask, everything else remains the same, but you have opacity mask, and we connect it to the alpha of the texture. This is the alpha output, and I'll put it to a box here. It's easy to see, but you can now see the outlines of grass, but the grass is still black. So I'm also going to connect RGB to base color. We have grass as no longer black, but it's too reflective. You can see there's a reflection of light on it. So I'm going to solve that very simple by just setting specular to 0 with a constant. Now we have this. Now one more problem is you can see the grass is invisible from one side of the polygon. There's actually a property called two-sided, and if you enable that, the material is visible from both ends. This is great for anything to do with like glass, for example, vegetation, certain magical effects or other special effects. All of those should probably be set to two-sided. Okay, and then we have our basic grass material. Masked is used for anything that is either entirely visible or entirely not visible. It's essentially a simplified form of translucency. Except this one doesn't support fading. It doesn't fade from one value to the next. It's either 100% there or not. That makes it ideal for example, a chain fence. It makes it ideal for vegetation, grasses, leaves, anything like that. Rendering something in masked is much more optimized than rendering it in translucent, which is the next thing we're going to do in the next section. So masked is going to render way faster. Therefore, if you can use masked, please use masked, and you will have a much better performance and fewer rendering artifacts. This is the safer path to take. Let's apply this to the model as well. Lastly, we'd like to work with translucency and therefore create a gloss material that's going to be applied to this statue over here. So again, right click, new material, m_gloss. Let's open it up and let's maximize the view. In this case, we're not going to use any textures at all. We're simply going to use a color. So here's a constant 3 vector connected to base color. This is going to be the tint of the gloss. So let's make that slightly bluish. And then we'd like to use opacity instead of opacity mask. So opacity. So we're going to set blend mode from opaque to translucent. That gives us opacity. It also removes metallic, specular, roughness, and a couple of other things like normal. But we have opacity now. So we're going to add a constant 1 vector to opacity. It's now invisible because the opacity is 0. If the opacity would be 1, it would be 100% visible. If the opacity would be 0.5, say, it's 50% visible. Let's try to apply this to the model in a level, but we're going to notice there's going to be an issue. Or not really an issue, but it's not really going to look as we'd like to have it. So I'm going to drag that onto the statue. And once it's compiled, you can see, yes, it is translucent, so we succeeded in doing that. But it doesn't look particularly realistic. It has no reflections at all. It's a very simple form of translucency. So let's try to make this a little bit nicer and a little bit better. It's using a very simple form of translucency right now, because translucency is actually really expensive and really complicated to do in real-time rendering, in particular in a deferred renderer, which is what Unreal Engine is by default. Because of those complications and limitations and the performance impact, you should be rather careful with translucent surfaces. So by default it's set to a fairly careful setting, but we can change that. We can go scroll down here to the section called translucency, and we can tell it that it should have screen space reflections at the very least. So we enable that. And then the next thing to make it a bit better would be to change the lighting modes, the way the lighting interacts with the translucency, and change it from the very neutral, simple, volumetric non-directional, which is a pretty cheap and simple way of shading the surface, and set it all the way to the most expensive and most complex one, which is surface forward shading. Now this is going to take longer than usual to compile, so you're going to notice some longer delays than you've noticed before the material shows up. Now, because we set it to lighting mode surface forward shading, we actually got metallic, specular and roughness back again. So we're going to add a couple more constants and say that roughness should be 0, the glass is 100% smooth, and metallic should be 1. And once you're done with that, you can apply or save it, and we can take another look in the level, and it's going to look much better. Again, it's going to take longer than usual to compile, so please have some patience. It could take up to a minute before you might finally see it. The reason why it can take such a long time to compile is already an indication of how heavy this is. This is much heavier to render. What we've done here by enabling these two settings is we've made the most expensive, most complex form of glass possible in the Unreal Engine. So this is expensive. If you're planning on building something that's going to use a lot of translucent surfaces or a lot of glass, please be very careful. I would really advise you to do further reading into this and not just create every single material you're working on, set it to the most expensive combination of settings like we've done here, because you will probably run into performance problems if you do so. The settings as we've used them here are only justified when you need the absolute highest possible quality for that particular material. In all other cases, if performance is a consideration, you should probably experiment a little bit with trying to get a good effect going without using surface forward shading. So again, further reading and further research is strongly advised. Right, so we've gone through the most important material properties. We've taken a look at the shading modes, in particular the unlit shading mode as compared to the default shading mode, and the translucent blend mode, as well as the masked blend mode as compared to the opaque blend mode. And we've touched upon the two-sided property and translucency settings. We've reached the end, and I hope you have found this Material Essentials concept course interesting. During this course, we've gone through everything related to the essentials of working with the material editor of Unreal Engine 4. We've made different kinds of materials, using features such as world position offset to drive the animation for a curtain, taken a look at how to alter PBR textures and materials, and how to work with translucent and masked materials. What we've covered in this course concerned only the material editor itself. But the Unreal Engine material toolset is made up of a lot more tools and features than only the material editor. And that's something we will dive into in the course on material workflow, where we will further expand on these tools and how the material editor fits into the bigger picture.